If you Google Go REST API, the first result will be to the official Go web page. Tutorial: Developing a RESTful API with Go and Gin. In the example, you will build a music album API. However, the problem with this tutorial, it got a very dangerous bug inside the code. If we click here on the completed code, we can see the full source code for this tutorial. And it's not that many rows. So what I done is I copied the code and created a local project from it. Here inside my code editor, I have the exact same example. And we can see there are 3 routes. One route to get all the albums, one route to get a specific album, and then there's a route to post an album. If we go to the post album section, if you look carefully at this code, can you notice anything? Can you spot the bug? It's not that obvious, but there is a very serious bug hidden here. So this example is written with the framework Gin, but it doesn't really matter. It would be the same for other frameworks. So what happens is whenever Gin will receive a request, it will spawn a Go routine. And the Go routine is basically like a small thread. The reason why it spawned a Go routine, that's because it should be able to process multiple requests at the same time. However, imagine what would happen then if there is many requests coming in at the same time and all of them trying to update this album slice. So if multiple Go routines would try to append to this slice at the same time, what could happen then is data loss. So imagine that you have like multiple users working at the same document and everyone makes edits at the same time. Meaning for some people that modify this document, they will feel like the state of it is invalid. That's not the data they entered in the document. For this example, I have written a script that will demonstrate how the data loss could look like. So here in the project, I have a file called test.shell. So let's go through what this script does. The first thing we do is we do a curl request to albums, and then we use JQ. That's a tool to working with JSON in the terminal. So we get the length, how many albums are there, and we save it to this variable. And then we start a loop. Inside this loop, we use a tool called Hey. And Hey is a tiny program that sends some load to your web application. So you can use it to like stress test the web application. I'm sending 25 requests with 25 concurrent connections. And this is the data I post. And then I wait for them to finish. Then we do a new curl request where we check how many albums are they now. And because this will send 500 requests, so if we take the before count and then add 500 to it, and then we subtract the count of all the albums after we did this 500 requests, if everything worked as expected, that means the lost variable, it should be equal to 0. However, if lost is greater than 0, that means we are experiencing data loss. So let's open up a terminal. The first thing we can do is to start the Gin server. So I will run go run /, and we can then see here that we have started the Gin server. And let's now try to run the script. So in another terminal, we can say /test.sh. And then we can see here, so from the beginning, we had 3 albums already stored. And because we know we're going to add 500 albums, we expect the value to be 503. But after counting all the albums, we can see we only have 500. That means we lost 3 of the albums. And let's try to run this a couple of more times and see what happens. And here we can see we have a loss again of 4 albums. And let's try again. This time 6 albums. And then let's try one last time. And this time we had a loss of 1 album. As you can see, this bug is very dangerous. And now you might be thinking, okay, great, but how do I actually fix this? In this project, I created a folder called fixed, where I have another main.go. And let's open this one up and see how it looks like. And here we are using something called RWMutex. So what RWMutex does, it lets multiple Go routines reads data at the same time. But when someone needs to write data, everyone else must wait. And then we declare this variable here, so albums mutex. So if we now go to the post albums, what we can see now is every time we're going to get a request here, we're going to say album mutex lock. Then we will do a append, and then we will do a unlock. So what this means is, let's say we get 100 requests to these post albums. The first request comes in, then all other Go routines, they must wait until it's their turn. Request number 1, modify albums, and when it's done, it's unlock the lock, and the next request can start modifying the albums, and so on. So basically it will become like a queue. You have to wait until it's your turn to modify the data. By doing this, we can make sure no data loss will happen. And then when we're trying to read the albums, we also put a lock. But instead of saying lock, we say rlock, and that stands for read lock. So what that means, if we get in like 1,000 requests to read the albums, all of them can read the albums at the same time. However, we lock it so it won't be able to write to this data before all those requests are finished reading the data. And then we basically do the same here for the get album by ID. So the takeaway here when using RWMutex, only one Go routine can write the data, but multiple Go routines can read the data. So let's now try this out. So if we open the terminal again, here we can kill the old example, and then we will say go run / and then /fixed. So we have our updated example running, and let's then try to run the test again. So we can clear it here, and then we will say test.sh, and then we can see expected 503, actual 503. And let's try a couple more times, and then we say expected 1003, actual 1003, and so on. So we can now see that no data loss is occurring. If you like this video, don't forget to subscribe and give it a like. Also, the source code will be available in the description. Thank you so much.